On number 2, we are to find the exact value of the inverse sine of negative 1/2. And the key to understanding this section, in my opinion, is to recognize the importance of the question, at what angle, and this is the question you're going to translate these expressions into to help you think about them. At what angle is sine equal to negative 1/2? In other words, at what point on the unit circle on the right side is the y-coordinate equal to negative 1/2 is what we're really asking. And the more you can think that way, the sooner you'll know the unit circle and the more useful it will be to you, and the better you'll understand these inverse relationships. So when we ask ourselves that question, and we remember that on the right side of the unit circle, sine is positive in the first quadrant and negative in the fourth quadrant, we know that our answer has to come from the fourth quadrant. So since we're looking for the point in the fourth quadrant where the y-coordinate is negative 1/2, remember that comes from the 30, 60, 90 triangle and is the short leg. So in other words, when is the short leg vertical on the unit circle? It is when the 30, 60, 90 is laying on its side, which means that our answer is negative pi over 6, or 30 degrees. I want to take a little moment here to sort of sidestep the examples to help you think about tangent on the unit circle, because our next example is pertaining to tangent. So remember, in the first quadrant, the 2 points that are harder to remember for tangent are at pi 6 and at pi thirds, which I've marked here, because the center angle in the first quadrant and in each of the quadrants is where tangents y and x coordinates are equal, other than give or take a sign, which means that at the fourths all the way around the circle, tangent will be some version of 1, and it will be positive 1 in the first quadrant and again in the third quadrant, and then negative in the other two. Well, then when you look at these other two angles at pi 6, we go to the right further than we go up, so our x-coordinate is bigger than our y-coordinate, so our x-coordinate has to be the square root of 3, and our y-coordinate has to be 1/2. And then you just reverse those coordinates because the sides change places when we reorient the triangle, so that you go over 1/2 and up the square root of 3 over 2. Now what all this has to do with anything is that when you are working without the unit circle, which you will be very soon, you'll be able to think it through if you don't know it right off the top of your head. So here we've labeled these values. So then when we think about tangent, there are some important number relationships here we need to understand. And the first one is that the square root of 3 over 2 is bigger than 1/2, as I just alluded to. And then the results of dividing either of those by the other are the square root of 3 over 3 and the square root of 3 itself. Let me make that square root bigger. The square root of 3 itself. Well, clearly the square root of 3 is bigger than a third of it, so these relationships are important to understand what I'm about to say. And that is that since tangent of any angle is equal to y over x, at this point, at pi 6, that means that our y, which is 1/2, is on top of our x, which is the square root of 3 over 2. So that would tell us that at this angle, that is the tangent of pi 6, this has to be the square root of 3 over 3 because the smaller number's on top. So then when we reverse that up here at pi thirds, now when we do y over x, the big number's on top, which means that the tangent of pi thirds is the square root of 3. And I know you labeled those the other day if you followed my instructions, but at the same time it's good to think about all those relationships just so you don't find it confusing later. So let's look now at number 10, where we are to find the exact value of the inverse tangent of negative square root of 3. So that's why I stopped and interjected that little mini lesson on tangent for you. So this statement is converted into the question, and I will stop and write it just in the interest of trying to help you think this way, and that is, at what point, and I'm going to go all the way to the most sophisticated form of the question, at what point on the right side of the unit circle is the y-coordinate, or not the y-coordinate, I'm sorry, now we're talking about tangent, is y over x equal to negative square root of 3. Well, again, inverse tangent requires that we give answers on the right side of the unit circle because that is the domain restriction. So if we're looking at the right side of the unit circle again, we know that because tangent is negative, once again we're in the fourth quadrant, and if you're thinking the way I was showing you a minute ago, that means that we're further away from the x-axis now, so this happens at negative pi-thirds. Number 14. This one says use a calculator, but this one can actually be a little bit tricky because of the fact that we are asked to state our answer in degrees. In general, I think you're going to be better off if you just leave your calculator in radian mode, which is why they default to radian mode when they set the calculator at the factory. If you leave it in degree mode, then you're going to have problems with all the ones where you have to do radian, which is in all the word problems and that sort of thing. So you're better off to stay in radian mode. So if you do this in sort of a two-step process, and first just type in what you see, and you should be in radian mode, and if you are, when you type inverse sine, and remember the arc sine is the same thing as inverse sine, then the inverse sine, and I'll write that out to remind you that that is the same thing, inverse sine from your calculator, because your calculator should be in radian mode, should come out to be 0.734209. Well, then we want to convert that to degrees just because the directions told us to. And so to do that, remember, we're just going to multiply by 180 degrees over pi. You're not going to put the degree symbol in your calculator. You'll just put 180 divided by pi, and you should get from your calculator that our angle measure in degrees is approximately 42.0671 degrees. Now the next one, which is much easier, is sort of the same thing, except they allowed us to leave our answer in radians, which is the mode your calculator should be in. So all you have to do on this one is just type it in, and when you do, you should get 1.52696. And you're finished with that one. And remember, if you don't put a symbol, that means radians. If you want to make sure the whole world knows, you can include, in fact, let me just do that. You can actually write RAD for radians, but you don't have to. If you write nothing, that means radians. So if you leave off the degree symbol and you mean degrees, don't cry when I take a point. All right, number 24. Find the exact value without a calculator. Okay, on these we start with the inside because it's an expression, so PEMDAS still dictates the order of operations, so we start inside. So we're going to keep the sign on our first step, and yes, I expect to see this all written on your homework. So we start with the inside, which says at what point on the unit circle on the right side is the y-coordinate, or not the y-coordinate, is the tangent 1. And remember, tangent has two choices on the right side where it's 1. It's either in the first quadrant or the fourth quadrant, because that's the only two that we're allowed to give back. And that has to happen in the first quadrant on the right side, so that would be at pi-fourths. And we happen to know that the tangent of pi-fourths is the square root of 2 over 2. And our last item for this video, another one says find the exact value without your calculator. Again, we start inside because it's an expression, and we start inside the innermost parentheses, and the cosine of pi is what we will find first, and that is going to be -1. So now we ask ourselves, at what point on the right side of the unit circle is the tangent -1? And that is at -pi-fourths. And that's the end of this video and that example.